It's great to be here. Thank you for having us.
And it's your show.
Excellent, excellent. So let's get started. So Cloudistics, we're going to walk you through what we're seeing and what we're going to hopefully present to you as the fourth generation of infrastructure. So we'll define all that for you as we go through this. Hyperconverged is definitely a very interesting place to play, but as we're seeing the market emerge, we think there's another iteration of this that people should be looking at, and we'll kind of define that for you as we walk forward. So hopefully you'll get some good takeaways, some interesting thoughts, and we'll be willing to take any questions as we go along. So any presentation that doesn't start off with a big, bold claim isn't a great presentation. So here's our big, bold claim. Basically what we've said is we're an all-inclusive platform that includes both hardware and software, and it gives you the basic flexibility that you had from a scale standpoint of the older converged platforms, the FlexPods and vBlocks, with that simplicity that we've come to know from the hyperconverged infrastructures. And we've also rolled in a very cloud-like experience. So you're getting kind of the best of both worlds and the cloud experience. So that's basically, in a nutshell, what we're claiming to be. So for the balance of this presentation, I'm going to do my best with Carmela to prove that. So when we look at it, we like to start out with the cloud because a lot of people are really starting to gravitate towards the hyperscalers in the cloud today. And there are a lot of great things that are going on out there. And in order to make that big claim, I've got to address those pretty much out of the gates and then wrap those into the balance of the conversation. So when we look at the large players like Amazon and Azure, Google and SoftLayer, they have a lot of great things that they bring to the table, right? They have this idea of unlimited scale, the ability to just continue on forever. And they do make things really, really fast. A lot of times when people are jumping into shadow IT, it's not because they want to go to Amazon per se. They go there because they can't get stuff fast enough from their IT organization. So they have a credit card. They can go out and get it done in a matter of seconds. It's really easy to use. If anybody's ever deployed an Amazon instance, and I have, super simple. Even a sales guy like me can do it. And then, when we look at costs, both from a modeling standpoint and a cost of entry standpoint, and, Amazon is pretty inexpensive to get into, and it does give you the ability to pay by the month. Now, that's a good thing when you're starting, but not necessarily the right thing in the long run. So, when we flip over to the cons of the cloud, you've got a scenario where you're locked in. Amazon, at least in the United States, and all the other cloud providers have a no guarantee of erasure. So if you put your data in there, it is pretty much Hotel California. Once you go in, you're never getting out. It also has a lot of constraints around sizing, right? So if you've got a specific application that needs either a specific type of machine type or certain characteristics around IOPS, you don't have that flexibility. So when I talk to my customers and we're talking about cloud, I basically say, look, you have to make your application match the system, not the system match your application, and that's just a natural side effect. Visibility is an issue, right? And we're not necessarily talking about security. We're talking about jumping into the public swimming pool. So you never know what the guy next to you, what he or she's doing. So, you can see what's going on in your portion of the pool, but have no clue what's going on around you. So for some companies, that's okay. For some workloads, that's perfect. But for high bandwidth requirements, workloads like Splunk and Hadoop, and for large database workloads, that may not be the best thing. And then a lot of people, when they jump into these scenarios, they forget that they're moving that workload off-site. So they may not think about, oh man, I actually have to get some bandwidth and connect to that thing and actually make a usage profile very similar to what I had on-prem. That adds cost and complexity. And then lastly, if anybody on the phone has ever used one of these footprints in an Amazon or an Azure or something like that and had a 24/7 workload, those costs, although they start out low at 2 cents per hour, add up to literally, for some of our customers, tens of thousands, if not hundreds of thousands of dollars a month. So, those are some of the things that we will need to address in order to make that big, bold claim. So when you look at putting everybody side by side, we've already gone through some of the cons associated with the public cloud. Let's talk about integrated systems. And I use that term specifically because that's what Gartner classifies hyperconverged, right? We've got footprints that are what I would consider converged, the vBlocks and the FlexPods in that particular classification. And we also have the hyperconverged players like the SimpliVities and the Nutanixes in that world. And when we look at those comparisons, these things may not fit each one of those things, but we put them into Gartner's bucket. So when we look at this, we talk about operational complexity. If you've ever deployed a FlexPod or vBlock, they're pretty complex. It's a lot of moving parts. And from a time to market standpoint, those environments spinning things up, they take weeks, months sometimes. So, the old versions of Converged in this integrated system footprint, they are expensive and slow. When you look at the newer hyper-converged platforms, they're awesome, right? They've got small chunks and things like that. But what we've seen over time is that because they've put everything into one chunk, you get storage, compute, and memory into one piece of equipment, you get this side effect, what I call, and I don't know if the industry's put it out there, but I'm calling it resource drift. And basically what that means is if you've got a resource that is constraining, like memory, which is usually the resource that we're going to see that's going to constrain on applications, the other components come along for the ride. And if I have to buy another node or whatever the chunk is that they call it that day, I'm going to get those extra resources in that ride. So, I had to describe this to my wife. And the best way to describe it for somebody that's non-technical is Neapolitan ice cream, because everybody understands that analogy. And for me, strawberry is my least favorite flavor. So I'm going to eat the chocolate and vanilla, and every time I go to buy more chocolate and vanilla, I'm going to get strawberry coming along for the ride. So as I add 15, 20, 30, 100 blocks of this Neapolitan ice cream, I've got a large buildup of that particular resource sitting there that I can't do anything with. So we see that happening pretty much in single use case footprints with hyperconverged. You get inefficient provisioning because when you're doing things like Hadoop, and you have footprints that have RF2 or RF3, those platforms are already doing data locality, so you're going to get RF2 on top of RF2, so it's not really going to be super efficient. And then at the end of the day, some of these hyperconverged platforms are pretty expensive. So what we've done in our platform is try to address all of those cons that we saw in the cloud and address the cons we see in the integrated system in a platform that we're calling a composable platform. So to do that, we have to have a simple management interface because a lot of the hyperconverged ones have super interfaces, right? We have to have application flexibility, which we'll show you in a couple slides. We think in today's world, if you do not have the ability to do multi-tenancy, you're not answering the mail. So our platform is fully multi-tenanted, and we'll talk about that in just a few minutes. You've got to have the ability to run at bare metal speeds, have incremental scale for both storage, compute, and memory, and ultimately give people the ability to consume all of those things in a cloud economics platform. So as we look at that buildup, so I like to do things pictorially. When we look at the integrated systems, so what I call the Act 1 version of that, you've got a lot of things that go into a converged platform, right? You've got networking, you've got computers, you've got fiber channel switches, storage has to come there somewhere, right? And ultimately hypervisors, right? So that stack is what you're going to be managing in the traditional FlexPod. When you get to the applications, that's what people want to use. At the end of the day, that's what they care about. And in order to get there, I had to build this big stack of stuff in order to get to an application. So not only do I have complexity getting to the application, God forbid something breaks. I've got to then troubleshoot through these different tiers. I've got multiple management interfaces, and it's just really complex, right? So Act 2, when we look at the hyperconverged guys, still have switches, right? They're sitting there, and we still need the switches in that environment, but they've done a great job of converging that storage and compute platform into one block. They'll have hypervisors in most instances, right? They're still going to be working with either ESX or Hyper-V, and in their world, the application is still what I call a second-class citizen. So, we've gotten close there, right? Iteration 2, hyperconverged, is actually a pretty decent answer, but we think we can get a little bit closer. So with Cloudistics, we've built a platform that takes all of those components and wrap it into a single platform. And I'll describe that on the next slide. But it includes all of that stuff that's in the stack in the platform. And it's all contained and managed in that platform. We also say that the hypervisor should be a feature, not something that I buy or something that I have to manage, so it's wrapped into the platform as well. And then lastly, we want to promote and have promoted applications to being first-class citizens. So in this environment, not only do we think about applications, but we actually have an application marketplace that we'll show you in a demo, where you can actually deploy, orchestrate, in literally in a matter of minutes, deploy complex applications like Cloudera and Splunk and anything that we think we want to roll here, either as a vendor or as our customers, and do that from this SaaS-based portal. So we think that this Act 3 is where people need to be, and this is the trend line for hyperconverged. So as you move forward, what is Cloudistics? So I've said it's a platform. So it's inclusive, it's hardware and software. So as you can see in this picture, and this will be the last time I talk about hardware, it includes switches, servers, so that block in the middle of servers, and storage, all based on off-the-shelf Dell components, right? And we basically have rewritten or overwritten the operating system on all these. So we have control of all the attributes of these particular things, and that's important because ultimately we need them to interoperate as one seamless block of components. And we'll talk about why that happens a little bit later. Now, when we look at this from the cloud portal standpoint, we've centralized everything. That layover, that overlay of operating system basically takes all of those hardware assets and turns them into resource pools, and they're federated resource pools. So from a storage standpoint, from a compute standpoint, and memory standpoint, we see those just as big pools of stuff. And we have the ability there to carve them up. So what that gives us is a couple of things. Centralized management is now done through an interface that thinks in terms of, I want to give this VM certain resources, and I don't really care where they're coming from. You've got independent scaling points. We're eliminating that drift that I talked about earlier. So if you need storage, buy storage. If you need compute, buy compute. If you need more switching ports, buy switch ports. And it's all integrated into that footprint through this cloud portal that we have. And then from a performance standpoint, because we've taken control of all the attributes of the platform, we've eliminated all those traditional file systems that you've heard about over the presentations before us. So underneath the covers, your virtual machines that live inside of our hypervisor have direct block access to the flash storage that's running underneath. So that means those VMs are going to be doing 40,000 IOPS per virtual machine and really crush it from a performance standpoint. And that's pretty much a guarantee from us. So when you look at those things, super, super important for large data workloads, big data workloads. The last thing here, because we've rewritten the operating system on all these things, is that the idea of multi-tenancy, right? We want to be able to have the ability to have full stack multi-tenancy. So what we've done is we've given you the ability to partition those resource pools physically, and that will give you hard boundaries. And inside of those physical partitions, you can also partition them logically. What that does is a couple things. One, it allows me to give you different organizational structures, either based on a physical partition or a logical partition. It also gives me the ability to eliminate noisy neighbor. Now, as I said in the beginning, when you look at traditional hyperconverged platforms, and I've worked for them in the past, this is an impossibility. It just simply can't be done with a converged storage platform across multiple nodes. So by the way we've done this, we've given us the answer that we've been looking for at least a decade to switch to block multi-tenancy. So we think that this is something that is table stakes for this particular type of scenario. Now, we did say we promised simplicity, right? So if you've ever deployed a FlexPod, and a lot of us have probably deployed those in the past, you should recognize this big pile of screens. In this, you're looking at an SSH session to get into a switch. You're looking at ONTAP and OnCommand. You're looking at the UCS manager interface that you need to get into and manage your UCS components. And you're looking at a very complex cabling schematic that comes directly from NetApp. Now, we view that as, that's okay, we can work through that, but why? So our cloud portal basically takes everything that we just talked about, and this is what you work with. This is what you work with to manage those hardware components. It's what you work with to manage your zoning and tenancy, and this is ultimately what you work with to manage all of your virtual machines and networking. So never logging into a switch, never logging into a server. I mean, if you want to do that, you can. Obviously, you have full control at the console level, but you don't have to do that ever again. So it makes it easy, simple for somebody like me to actually be able to do this. And as promised, we also have given you the ability to actually deploy those applications from an onboard marketplace. So as we develop more relationships with different vendors, you'll start to see this explode, but you'll see us having the capability of deploying things like Splunk, Cloudera, Hadoop, Docker, and I didn't discuss this earlier, but the platform by default is natively Docker ready. So we made the decision out of the gates to make sure that we could manage containers from day one. So that gives us a couple of different feature sets. One, it allows us to make our cloud portal, the brains of the operation, it makes it such that we can put it in a container. That gives you the ability for portability. But secondarily, we know that every workload is going to have different characteristics, and not every workload is meant for an on-premise cloud. Some workloads are going to go to Amazon. What better way to move things between the public cloud and private cloud than through containerization? So we needed to make sure that we supported base containerization out of the gates. So we will support the deployment of the core Docker engine here, and as part of that, we'll also support all the major orchestration engines, including Swarm, Kubernetes, and Mesos. So you can do all of your container work in one tenancy zone, and do all of your traditional regular server work in another zone. We also know that we need to have that application flexibility, right? So general purpose workloads, those are where I think most hyper-converged players play well. And we definitely play well in those workloads, absolutely play well in those workloads, but we've decided to fight the fight a little further up the food chain. So when we designed the platform, we were focusing on things that were hard. So things like containers, things like big data, things like Splunk, things that need to ingest a lot of information really, really quick, are things that we strive and perform really, really well. Most of our clients today are either big data, Splunk, or container users, and we've targeted those use cases specifically because it is challenging for other hyper-converged players to actually play in this space. Now, that doesn't say that I can't run your SQL Server workload. We did a test with a customer. They were doing a bare metal server against a under-provisioned virtual machine in our platform, and we smoked that SQL Server 8x. I mean, we literally outperformed the bare metal server. So we'll work with any workloads, but if we can handle the hard workloads, the little ones, the big ones are hard, the little ones are easy. So all of that is managed through the same interface. Use that multi-tenant fencing to pin them apart from one another, and it gives you a lot of flexibility around how you would manage this platform for multiple applications. So when we look at being able to show you that application first footprint, we wanted to walk you through a quick demo of how it would look to deploy Cloudera inside of this footprint. So I'm going to hand over the speaking to my friend Carmelo, and he's going to walk you through a quick demo that we did around the deployment from this marketplace and the deployment of Cloudera. So I'm going to click this. Hopefully this works, and Carmelo is in charge.
Well, first, it's nice to meet you guys. Thank you very much. So you'll notice we just went into our marketplace, and we picked a Cloudera template that's pre-installed, pre-configured, and performance-tuned for Cloudera. We're creating a 4-node Cloudera cluster on top of the platform, and we're going directly into the Cloudera manager and starting the install. You can do this in an automated fashion as well, but you can't visualize the automated fashion, so I wanted to show you this way. You log in with admin, which is the default passwords for the Cloudera Manager install. You accept all the EULAs. You decide to install Sun JRE because you need Java. You pick their 60-day license because we're just doing a demo here. You put in the IP range that you want to scan for to find your fully qualified domain names of the nodes we created. And those are actually all provided via microservice within the platform that includes DHCP and DNS. You go out there, you scan the nodes. You keep on going with the install. You put in your root password, which for these VMs is Cloudistics. You get a successful install. You move all the data to all the nodes. That's so you can start actually picking up what's going to be your node server, your NFS gateway, kind of more Hadoop-like components for the install. Cloudera does a quick check on all the nodes, make sure that FQDNs work correctly, you have the right packages, the right performance settings, which you see here that we do. You pick the type of Hadoop installation you want to use. You select all your nodes and where you want your applications deployed. And keep in mind, this is about making applications the first-class citizen. Everybody throughout this demo that I've seen today is all about the infrastructure. Nobody actually talks about your apps. Here you're just running a test to validate connectivity, and then you have a fully configured Cloudera cluster. You know, that's 2 minutes, guys. I don't know anybody that could deploy Hadoop from cradle to grave in less than 2 minutes outside of us. No, by the way, every VM is performance tuned. You can do 40,000 IOPS. You get whatever you've allocated from vCPU and memory. It's a really unique capability.
Yeah, so you guys, this is the thing that we think that hyperconverged really needs to start looking at is that application first footprint. So the last thing that we wanted to throw into this particular conversation is the scaling methodology. So I know a lot of people have talked about pay-as-you-grow type of scaling today. We've taken that one step further. So obviously in a platform like ours, we talked about resource drift earlier. You can obviously pay for and buy resources on demand, and that's at each incremental level. So we're not tied to a node or a block or anything like that. But the other thing that we've also added to this is a consumption model, and we think this is unique in the industry. So basically what that gives you as a customer is the ability to come in and say, okay, I know basically what my footprint's going to look like, but I really don't know what my utilization is going to look like. So what I'd like to do, Cloudistics, is I'd like to consume based on resources. So basically two axes. Time is going to govern what you pay, and then ultimately the base commitment of utilization on both CPU and storage, and you can literally pay by the month. So we figured that in order to make that bold statement of being like Amazon, Google, and Azure, we needed to come up with a consumption model that is available today for people to get in and actually consume resources as they use them. So we think this is unique and should be part of the whole hyperconverged footprint as time goes on. So to basically summarize everything, and this is the last slide, and this is what we tried to show you today. So it is a complete platform, right? We're giving you everything that you need in order to manage every aspect of a cloud platform. Networking, storage, and compute managed with a single interface that's really simple to use. Because we give you that tunability, we've eliminated that application fitting the system, not the system, that whole thing around cloud. So you now have application-specific flexibility, and you have the ability to roll applications into the marketplace. Multi-tenancy absolutely has to be a must in today's world. So if you're talking to your hyperconverged players and you ask them the multi-tenancy question and they give you a blank stare or start dancing around it, you should demand that they answer the question. High performance is an absolute must in a hyperconverged world, and it should be something that you see in the cloud. And then ultimately, you've got to have incremental scale, like we've talked, no drift, and the cloud economics. So with that, our ask of anybody that's here is we want to show this to you. So we'd love to meet with you. We'll do a demo for you at any point in time, and then ultimately we'd love to get you in and let you test drive this at any point in the future. So with that, that's the end of our presentation. I guess we'll open it up for questions.
We will. In fact, we have a few questions that have come in. One of them is a statement, but in the form of a question. That says, I've read that your total cost of ownership is better than AWS. Can you speak to that a little bit?
Yeah, absolutely. So we based on, if you do using instance types, and I've done this against on-demand and different reserve types, we see on-demand that the total cost of ownership of the platform versus an on-demand instance footprint is roughly 1/3 of Amazon's footprint. When you get into reserves and you're looking at a traditional 1-year reserve, roughly 50%, and on the 3-year reserve, it's about 45%. But that's, it depends on instance types and density, but you can see anywhere from 70% to roughly 45% total cost of ownership over 3 years.
And we have another question here that's sort of interesting. It says, finally, a reference to microservices. So kudos to you. Are there any suggested microservice architecture patterns that work in the Cloudistics environment quite well?
Carmela's going to take this one.
Yeah, so I'll answer that one. I was actually writing up my response right now. So we have a couple of microservices that we provide today, like distributed firewalls that are done in an architectural fashion in that every hypervisor runs its own firewall, every switch has its own firewall. And that's more of a zone-based architecture to secure everything from the VM to the VM, north, south, east, west. Other microservices we provide are like DHCP and DNS. We have NAT coming. We also have HA proxy, so load balancing as a service as part of the platform instead of having to go out there and buy things like F5. And then we also support third parties. So if you're looking at Palo Alto, Citrix, F5, Cisco, you can run those virtual appliances that are traditionally deployed on VMware on us as well. So from an architecture perspective, we have our methodology, which is always zone, but you can also run third parties, which are more perimeter, i.e. put it up at the gateway, turn it into your default gateway, flow traffic in and out. But either way, you can secure your environment in ways you haven't done before, and you can segment it from cradle to grave, as Steve mentioned earlier.
Yeah, and our next non-networking microservice will be around file sharing. So we'll be releasing a file sharing microservice that will allow really robust up to SMB4 file sharing across the entire federation of storage. So yeah, we're looking at that in March.
That's awesome. Actually, I look forward to seeing that. This is an interesting question because it's, when people think about cloud, in fact, I'm sort of a big believer in the cloud is not a destination, but it's actually what the outcomes you're looking for. So the question the person asks is, would this be a good solution to implement, especially moving the physical data center cloud to Azure, or moving the physical data center to Azure? Now, Carmelo, you already answered this in the Q&A, but I think the rest of the audience would be well served by hearing the answer to this question.
That's awesome. So when you think about us and you think about things like Azure, if data locality is important to you, PCI compliance, SOC compliance, HIPAA compliance, you name it, the idea is we bring the cloud to you, right? When you think about moving things to an Azure and AWS, you have to worry about how to move that data on a routine basis, and then you have to deal with link and the cost of link, or the cost of moving that data. In our world, if we bring it to you, we eliminate that, we give you predictable performance, and we give you isolation and control of your environment.
So the only thing I would add to that as well is, to your point, cloud is not a thing, it's a destination. Whenever I'm working with customers, and I definitely am a believer in the public cloud, I tell them, look, the cloud, you need to do an assessment of workloads, right? So there's going to be specific workloads that will make absolute sense for going into Azure, but there's other workloads, like to what Carmelo was addressing, things that are high bandwidth intensity, 24/7 workloads that may not make sense going into Azure or Amazon. So I always caution my customers, really, really do an analysis of the workload first, and then make the cloud decision after that. We give you an alternative on-prem, but it may make complete sense to move it over to Amazon and Azure. So that's my counseling to almost all of my customers.
Excellent. Gentlemen, that's all we have time for, and we are going to move on to the final part of our presentation today. Thank you very much to the Cloudistics team for being here today.
Thanks very much for having us.